Hey guys!
Hello!
So last week we didn't do a workshop video because we did a hackathon instead. So you guys got 2 weeks of rabbit hole, or 2 videos of rabbit hole last
Woot
week.
woot.
But we were continuing working along, and last workshop video I had got triggering working on the drum section of that keyboard. And I discovered I needed an NPN to hack the chips. So you can see over here what I've done is taken these 2N3904 BJT NPN transistors, and I'm using them to jump over those switches. Like output A of this 595 shift register turns this transistor on. And that's essentially connecting one side of the switch to the other side of the switch. So I did the schematic for it really quickly. I added a couple extra features to it, like LEDs that come on when a transistor is enabled, the daisy chaining capability, all that kind of stuff over here. And over on this monitor, you can see the end result PCB. Lots of transistors, lots of LEDs, 595, resistor array, and then you got the input side of the chip along here, and the output side of the board along here. Yep. And the 3D version is here on the center screen. I know this one flickers on camera, you're just going to have to deal with it. The routing turned out really nice and clean. And we got it sent off to OSH Park, and it should be here before the next workshop video. So next time you'll get to see it in action, and we'll do some testing on the keyboard.
Okay. Yo, what is this? Cardiac Simulator V.0. I mean 0.0. Yes.
V0 just means prototype.
Prototype. A lot of work went into this. Like a lot of work went into this. So.
A couple of months, yeah.
Yeah. So this board, a lot of my pride and joy, is all the traces are on the back, none are in the front. And the reason being is because ba-bum, whoa, that is Cardiac Simulator V0.0, a heart. I know you love it. So the LED pads are tracing the nodal tracks for the atria and the ventricular bundle branches for the ventricles, as well as the sinoatrial node and the atrioventricular node. And then this side, well, these are the brains. I did have a few traces on the back. Power jack clearly needed big holes. And here are the brains. What do we got on the brains, Whisker?
Crystal.
Crystal.
Power jack, propeller, EEPROM, pull-up resistor array, decoupling caps, filter capacitor, heart rate receiver, mode switch, voltage regulator, I think that's the 5-volt regulator.
Yep.
Power switch.
Yep.
Audio jack.
Yep.
Audio amplifier. The transistor for switching the solenoid.
Ooh, good find.
And these are for the LCD module.
Correct.
And we've got the 3.3 volt regulator here, I believe.
Yep.
Some more filtering caps.
Yep.
And what's this one?
Programming.
Oh, programming header.
Yep.
And then there's one more header here. What's that one?
That connects it to this board.
Okay, so that's the display
Right.
driver
Right.
thing. I think that's everything.
Yep. So we're going to go ahead and put it together, show you guys the parts that are going to go into it, and go from there.
To give you guys an idea what goes into populating a board like this, here's the box for that particular project. all the different component values and switches and solenoids and jacks and everything.
A lot of different things, really.
And it's really not all of them. I don't see any props in here or anything.
Nope. Yeah,
So-
there's like 3 or 4 items that this box can't fit just yet, so not sure which ones to combine. Although this one's already a combo one.
We got an empty one here.
I know, yeah. That one I think is gonna get some NPNs into it. So we'll see.
Alright, let's get to it.
To it.
Alright, so we wanted to show you guys this one. What we did here was put the LEDs on
Mm-hmm.
and refloat it in the oven.
Numero.
Oven.
Oh, oven. Yep.
Okay. And then it had more SMT parts on the back.
Mm-hmm.
So what we did is after the LEDs were in place, we placed these on their solder paste and then set the board on these scrap PCBs so the LEDs aren't touching the tray,
Mm-hmm.
and then refloat the top. And the surface tension of the solder kept those LEDs from falling off.
Excellent.
Worked out fine.
Yep.
Okay, and then on the other side of things, this board took a long time to place by hand.
Yeah. Yeah. We've got the prop chip, we've got the EEPROM, we've got the voltage regulators, audio chips, different jacks, audio jack, power jack, programming jack, power switch.
I mentioned that we've got this pull-up resistor array.
Yeah.
One pin of it, this pin right here, didn't get soldered properly the first time. And that's the pull-up line for one of the I2C lines to the EEPROM. So I was getting some EEPROM errors, but I fixed it by resoldering just that one tiny pin.
Mm-hmm.
And then Addie made a slight error on how the power switch is wired up. This trace coming along here is going to the input, the VIN on the 5-volt regulator. It's supposed to be going to the center pin on the switch, which it does, but it also goes over to here. So when you turn off the switch, you're
Doesn't
not
really
disconnecting the regulator, you're actually just disconnecting this capacitor, which is the filter capacitor. So instead I lifted the leg on that VIN pin on the regulator and jumped it with a little red wire here going over to the switched line. So now the power switch works correctly.
Mm-hmm.
This is a prototype, so that's fine.
Thankfully.
Anything? I think that's all
I
so
think
far.
that's the only error that we found so far.
We've done a little bit of testing, which we'll show you. We've been able to test the switch successfully and the LED display output port. We haven't tested any further than that.
Right.
But we'll show you guys the thing booted up. This isn't how they're going to be in the enclosure eventually, but we did set it up so that they line up and you can just plug the boards into each other. And that provides the power, ground, serial, latch, and clock lines for the display board. Now I just jack in 7.5 volts, flip the power switch, and the EEPROM is running.
Look at that! It's like a... Whoa!
It's just some test code just to make sure all the LEDs are working, that the crystal is keeping accurate time, all that, and it's doing the mode switch. If I hold down the mode switch, it sends over serial that it's been held down. We don't really need to show you that because it's stupid easy. Yeah, so testing has started on the cardiac simulator.
Bam.
Now I got a tool this week that I wanted to show you guys that has helped a lot on this project, so we're going to head over to the bench.
Okay.
Alright guys, I wanted to walk you through the process here. We're assembling one of the little TTL8 boards for the MIDI shift project. As you can see, I've been assembling lots of them. Yeah, just going through the process. We've shown a little bit of it, but I haven't shown the whole thing, or the scope, which is working now. So we got the big microscope up here. Yeah? Mm-hmm. And the control for it back here, the driver for the light, is up here. So I can turn it on. If you look here, I've got total control of how much light comes through. And I can see what I'm doing. So what I'm going to do here is take my little board, look through my microscope, set my focus. I want to put a little bit of solder paste along where the legs of the chip go. Now the basic version of this board only needs just the IC installed. It doesn't need the LEDs, they're optional. And then one thing that I find really helpful for doing this is to take a pair of superfine tweezers and use those to smooth out the amount of solder that's on each one of the pads and just sort of swoop off the excess like so. Do the other side. This would be a lot easier with a stencil, but until the boards are finalized for full board production, there's no real point in making a stencil for the prototype. We just do them by hand. But to get these properly tested, I need to have enough of them to send out to the beta testers like John SAZ. We'll be getting these V0 boards. They'll be going into a project that he has in mind. So I'm going to make sure I do a really slapshod job so that John has to fix lots of bugs. Alright, so we've got that, and then I note where the circle is, and I note where the circle is on the chip, and orient them so that they are in the same corner. And then I drop it into place. And then just sort of bump it so it's lined up perfectly over the pads. One of those kind of people where very, very fine work makes my hands shake a tiny bit. So a microscope really helps with that sort of work. Makes it much, much easier. Okay, so now I said I wanted to show you guys a new tool. And that's back here. It's a hot air station. I'm going to fire that on. So it's warming up. And the tip here is a very fine tip. And I've got the speed set very low. And I've got the temperature set to 300 degrees. So what I can do with this is just come over the chip and direct some hot air onto the solder paste there. I could use this for removing chips or fixing things, but for this kind of thing, it's actually really, really super handy for installing just a single chip.
That's super cool.
Yeah, it's really nice. So it's already reflowed much faster than it would have taken in the oven. It's already done there, and there's just the one bridge. So I just turn on my iron. The bridge is on this side. I'm pretty sure you guys won't be able to see it with the camera. I just give my iron a second to warm up here. Hot goes pretty fast. Yep, there she is. And now the bridge is fixed. I have inspected it through the whole process while I'm doing it because I could see it in the microscope while I was flowing that solder. So I already know everything's good and I'm done with that board.
Damn.
Pretty cool, huh?
Mm-hmm.
Nice. So many years ago, I was at a little art fair and I picked up this turned pen. Some very nice weird wood. And yeah, I usually use mechanical pencils though. And Mike Burr, longtime Tymkrs, chatter in the chat room, viewer of the videos, you know, one of you guys, finally got around to saying, hey, let me turn you some stuff on my lathe, which I've been looking forward to hearing those words for a really long time because Mike is good at what he does. So he turned me a mechanical pencil, and for inspecting things rather quickly, a very nice turned matching magnifying glass.
Very nice.
So thank
Thanks,
you, Mike
Mike.
Burr.
Woo woo. We post videos all the time, so don't forget to subscribe and follow us on Twitter at TYMKRS.